Uh, Good morning. It's now 6:10 in the morning here in Los Angeles, California. I'm here at the Sheraton Los Angeles Airport. That is the Sheraton Hotel, Los Angeles Airport, 6101 West Central Boulevard. And I'm on the 10th floor, 11th floor rather, 1157, demonstrating the discovery of the amazing 5x12 matrix. In other issues, in other lecture session, video session, it has been described as 5x11 plus 1, sometimes just 5x11, as we have sometimes isolated the 12th column, which appears in many paperworks, monetary serial paperworks, separated from the other 11 economics configuration. So yesterday, here, same spot, same venue, we started on the application of the 3x3 paired matrix and the 4x4 in circuit analysis. And so I will take you back to one in which I did it, and we're going to do a recheck via Kirchhoff voltage law, Kirchhoff current law, and Ohm's law for the result we got. And I did it apparently off the video and found out that there was some mistake. So like any scientist, any engineer, we do a recheck on these things, and sometimes we come up with arithmetic mistake. Now the mistake must have been made in the calculation of the determinants. Easily you could make even a sign error, and just one error in one spot will throw off the whole thing. So sometimes you have to go and make a recheck. But we're going to check it by Kirchhoff voltage law, current law. So we take, say, mesh 2. Yours truly, Dolphy Gilpin, is your instructor. Mesh 2, which is this mesh, and we got down that I2 was equal to 0.5 amps. And let us just review. We got delta to be equal to, I believe, 800. And Ni2 to be equal to 400. I believe such was the case. We check here. Delta equals to 800 and Ni2 equals 400. So that I2 was then equal to I2 over delta equals to 400 over 800 equals 0.5 amps. So we go to mesh 2 and we check it. So we say, no, this is taking KVL around the loop here. We say, no, that this is plus 10 volts. The source voltage must be equal to the sum of the other voltages. So 10 volts is equal now to, V is equal to IR here. So if we use I as 0.5 amps, we have no IR would be 0.5 times I4, which is the resistance, plus now 0.5 times 3 plus 0.5 times 1. And this would come up to 5 and 2, 7, 8.5 is equal to 10, but 8.5 is unequal to 10. So there was a difference of a 1.5 voltage here. All right, if we say this was I'm just rechecking here. If this was I1 will come right here. This would be I1. So up to here, this will be I1. And if this is I2, then this would be I3 and I2. So we say now that I1 plus voltage going into this node, or the current going into this node, is I1 and I2. I1 plus I2 must be equal to I3, the current going away from this node. But we have I1 to be 0 from our determinant calculation, but since it was wrong, I think the 0 is really 0 in this case, but let's just go like that. Or we will take the KVL around this loop. Let's take KVL. 5, so 5 volts will be equal now to 2 times I1. And coming down now, we'll be coming in reverse to this one. So this would be minus I2. I2 is going this way, so it's coming down, it will be minus I2. Minus I2 times 4. And we're coming against this voltage here. So this was 10, so it's now minus 10. So 5 is equal now to 2. Bring over here, you get 15. And so we're going to calculate I1 and I2. So we use a simultaneous equation. We're doing it by the KVL method, eliminating the determinant method for the moment, because some mistake was made. It didn't add up. It's supposed to get 10 equals 10, and we get 10 equals 8.5. And we could have found out from the very beginning when we get the determinant here, because determinant of one using one column is supposed to be equal to the determinant of using all the columns. All right, so that's just a method that we use to recheck by KVL and KCL. So I'm just giving you the principle of it there, and you're going to go back and recheck to find out where the arithmetic mistake was made. So now we're finding it by KVL and KCL there, by taking it around the loop. And so we got 2 equations here and 2 unknowns. And so we could solve for I1 and I2 via the KVL and KCL and see what we come up with. And then we plug it back and see what amperage we get for it. So that is just a method of rechecking. And I've given you the principle of it. The principle of the determinant was also correct, but like I said, there was some mistake made with the signs or in the calculation of the determinant, which is sometimes not infrequent. And because we're dealing with determinants greater than 2 by 2, we're dealing with 3 by 3s and 4 by 4s, mistakes can be made. So I'm going to leave it at that and ask you now to recheck it by using KVL and KCL around this loop. If you have 3 unknown, we could bring in the 3rd mesh and solve it, independent of the determinant method. So that is the remarks on the calculation. I went back and rechecked and found that it didn't match, but they are very close and there was some error made because of the magnitude of the determinant. This sometimes happens in finding the determinant. So I'm going to go over to a 4x4 mesh and do some calculation by circuit analysis. But we're going to put in the elements now by inspection on the 4x4.